Hello all. Today we learn about how to minimize a function with two variable, three variable using K-map method. In last class we learned about SSOP expressions, how to map SPOS expression, as well as we learned a method cell adjacency for minimizing your functions using K-map method. So we need to follow some basic steps to minimize your functions using K-map. First step is finding the suitable K-map. How to find the suitable K-map is based on the number of variables in your given function. So based on your given number of variables, choose your correct K-map. So now if it is a two variable function, you chose your two variable K-map. If it is a four variable, you chose your four variable K-map. Upon finding or choosing your particular perfect K-map, then we can go for your function. Is it in represented as a sum of minterms or product of maxterms? So if they are given sum of minterms or in SSOP, so you have to place the logical ones into their corresponding blocks of your K-map, which is called mapping. So next, if your function is in SPOS form or product of max terms, then you have to put zeros in the corresponding blocks of your K-map in your respective blocks of your K-map. So this is known as mapping. Upon mapping, then we can go for the grouping of your cells. So grouping can minimize your function into minimum number of variables. Now we have to check for your always the large groups. Now so your groups will start with a 2 power 1. So this 2 power 1 cell adjacency is called the pairing. So next 2 power 2 is called your quad. So 2 power 2 is 4. So hence, so 4 square adjacency is called a quad. So 2 cube is 8. So 8 square adjacency is called an octet. 2 power 4 is 16. It is called 16 cell adjacency is called as a double octet. So always choose your large group. So based on your K-map. So if it is a 4 variable K-map, or actually in 4 variable we have 16 cells. So let you check for the 16 cell adjacency, which is double octet. If it is not possible, then go for your 8 cell adjacency, which is an octet. So now if it is not possible, then go for your quad formation with 4 square adjacency. If in the worst case, we'll go for the pair formation. So if it is not also there, so then we'll go for the isolated minterm, which is the single cell. So single cell will represent the max term or a minterm. So that max terms and minterms to be written as it is. Okay. So now we will always check. For example, now I said for your 4 variable. So I'll always check for your double octet. If it is not possible, then octet. Then if it is not possible, then quad. Then we'll go for the pair. If it is not there, that least pairing, so then you can go for the isolated minterms or max term. So this is the procedure. For example, I have a 2 variable function. Now my number of cells are only 4 in your 2 variable function. So if you have 4 cells, so the possibility of grouping is 4 square adjacency, which is your quad. So check for your quad formation. If with the given minterms or max terms, this grouping is not possible, then go for 2 square adjacency, which is pair. So then after that, if it is not possible with the 2 square also, so then go for your only the isolated minterm with the 1 cell, which is a isolated minterm. Like this. So check for your groups. Okay. Always check for the large group and form or cover all the minterms and max terms into that group. Okay. So next, so after forming that groups, then we can have to each group must be represented as a product term in your SSOP. each group is represented as a sum term in your SPOS function. So now upon having that product term in SSOP, sum all the product terms of each group, then you can get your Boolean expression. If you sum your, if you are taking the product of your all the sum terms in the SPOS, you can derive your simplified Boolean expression. Like this, that simplified Boolean expression is derived, and after this, so you have to realize with the logical gates as well as your universal gates. Now, I have been given an example of SSOP expression. So here I have not mentioned how many variable function it is. Then how to detect the proper K-map. So now, in order to find a proper K-map, so which is suitable for minimization, we need to check for the largest decimal code in your given minterm. So here the largest decimal code is a 2. So now this 2 is represented in the binary representation with 1 0. So the minimum number of bits required is 2 bits. So hence I will prefer a 2 variable K-map which is having 4 cells. Upon choosing the K variable, so now I need to check for your given function is in minterms or max term. So with the small letters they have given, small letter m they have given means, so these are your minterms which are the product term whose functional values are ones. So hence map your function. Mapping is placing or putting your ones onto the corresponding cell. So m0, m1, m2 are my minterms in my given function. So map your functional values in the corresponding cells of your 2 variable K-map. So 0, 1 and 2. Upon mapping, then check for the rectangulars or the grouping of your into a large square. Okay, so now I'll check for your 4 square adjacency because I have 4 cells, so it is not possible. Then I'll go for the 2 square adjacency which is a pair. So now m0 is adjacent to m1, so this one belongs to the pair 1, so or group 1. So now this pair 1 will give you the minimal expression which is the common variable. So now for this common variable is a and the assigned value on a is 0. Hence the product term become a bar, where for this minterm m0 it is 0 b value, and for m1 b value is 1. So which is different from m0 to m1. So that different variables are dropped, only the common variables must be present in the product term of your pair 1. So next upon this, then go for your next pair. So next pair. So here we have only M2 which is uncovered. So in order to cover this uncovered minterm, so now check for your minterm which is not covered. So here there is no possibility of no uncovered minterm with M2, hence I am using here already covered minterm M0. So then, so we can form a group which is called as pair 2. Okay, again here 2 square adjacency, so this which is a pair 2 or a group 2. So now let me check for these 2 minterms which is the common variable. So for this 2 minterm, the common variable is b, where the value is 0. But here for m0, a value is 0, for m2, a value is 1. Hence, so the different variable of a is dropped, only the common variable b is written into as a product term of your pair 2. Now, I obtain 2 product terms. Now, from your 2 pairs, so your final minimal expression is sum of your groups of products of your given 2 groups. So first group I have a bar, second group is b bar. Hence my minimal expression is equal to a bar or of b bar. Now upon minimizing your function, so which should not be further minimized. So then, so now we are going for your realizing your function using logical gates. So how to realize the function using logical gates? So now let me use here one NOT gate which can give you the complement, another NOT gate will give you the complement of B. So then one OR gate which will give you the your OR operation. So like that, so we can implement your function using your logical gates. So like this, so This is the realization of your minimal expression. So using your K-map method. So now as I have given A here, so next here it is B. So A bar and B bar is odd. So this will give you the minimal expression with less number of gates. So like this, upon minimizing, we have to draw the logical diagram of that minimal expression. Now let me minimize your SPYS expression. Now here I have directly mentioned how many variables it is. So with the alphabets of A, B, it's also a 2 variable. So where the given max terms are 3 max terms they have given. So 1, 2, 3, map your function. So since max terms are represented with capital M, their functional values are 0. So in the corresponding cells, so you have to put the zeros. Upon putting the zeros, then check for the group adjacency. So now cell adjacency, then group it. So now I have here group 1 like in the previous session. So now max term M2 doesn't have your pairing with M0. So hence it can use your already covered max term. Now, so group 1 can form a pair. So now this pair can minimize your expression. The common variable here it is B is 1. So where it is a SPOS form. So hence your minimal expression will come into the POS form. So if it is 1, so then it is represented with a bar. So for this group of 1. So next group 2 is a pair again. So now for this 2 max term, the common variable is A equal to 1 and the different variable is B. So B value for M2 is 0, M3 is 1. Hence group 2 will have the minimal expression which where A value is 1. Hence it is represented with complement. So now these two are treated as sum terms. So in your minimal expression of this, so you have to multiply these two sum terms. So first group minimal expression is B bar, second group minimal expression is A bar. Hence like this, so we have to minimize your function. Now what will be the operation between these two variables complemented is an AND operation. So in order to obtain your designing of logical diagram of this minimal expression, I need to use two NOT gates. So one NOT gate is connected on B, the other NOT gate is connected on A, and then I have to use one more and again in order to perform your AND operation between your B bar and A bar. So then we are going to implement a function which is B bar and A bar from this utilization of these two NOT gates and one AND gate. So in the same manner, so these three variable functions are also implemented. So M1, M2, M3, M5 upon mapping onto the three variable which is having 8 cells. Upon mapping again we have here two pairings. So now first pair will have different variables are A and common variables are B, C where B value is 0. So hence it is represented as B bar C. Next second pair is having the common variable which is A value 0, hence it is A bar, and in column wise your B value is 1. So C value is different, so it is dropped. So B value is 1, hence it is represented with the product term of A bar B or of B bar or C. So next, so another example M1, M3, M4, M5, M6, M7. So we map your function. So we check for your adjacency. 8 square is not possible, then I will go for your 4 square adjacency. So this is the group 1. Here we obtained a group 1 here. Another group A is formed with the, so here already I used your already covered minterms, so which are 7 as well as the 5th minterm I used to cover your 4 and 6. So group 2 both are quads because 4 minterms can form a quad. So now group 1 minimal expression is, here it is x is different for this x value 0 and for this x is 1. So next y value 0, y value is 1, only z value is 1. So hence it is group 1 is z, group 2 will give you the x value. So as a product term, so x or of z is the minimal expression of this SSOP. Next let me find the minimal expression for SPYS expression. So as it is SPOS max term, so we put the zeros into the corresponding cell, then we have grouped your the possible cell adjacencies based on that. So we group into two pairs. So first pair will give you the minimal expression as A is different, only B and C are common variable for these two max terms. So the sum term of group 1 is a pair is a B bar or of C bar. The second pair is having a common variable which is A is 1. So A bar or of, here column wise B is 1, hence it is B bar. But the last max term which is 0 max term, so this 0 max term doesn't have cell adjacency. Either if you have 4 or if you have 2, you can pair it, or if you have a max term 1, you can pair it. But in my function that was not there, so hence, so this is doesn't have cell adjacency, so this must be a one cell. So it must be written as A or of B or of C. So this is your actual final expression of. So now all these sum terms are multiplied, then you obtain your minimal expression of your given function. Next here I have given another one with a pi m of 0, 1, 2, 4, 6. So which is of 3 variable function. Now this 3 variable function I will check for your the octet. So 8 cell adjacency it is not possible. Then I am going for your 4 square adjacency. So as leftmost corner cells are adjacent to the rightmost corner cell, so I can form a quad. Now this quad which can give you the minimal expression which is equal to z, and here one max term which is left. So in order to cover that I am using already covered max term which is 0. So I can form with this a pairing. So this group will give you the minimal expression of some term which is x or of y. So hence our minimal expression is z. So product of these two sum terms. So z is the quad minimal sum term and x or of y is your pair minimal expression. So like this, so we were going to minimize your functions based on your given number of min terms or max terms. So I have given so many examples here. So with the answers, so try to practice and find their minimal expressions of 2 variable, 3 variable as well as in your SSOP and SPOS form. Thank you.